we continue to look at relations, functions, and graphs. We want to look at composite functions. Now, these are really two functions where they combine to form one function. So that one function that results is a composition of those two functions. It's like saying, let's say you have water flowing. You want to generate electricity, and you have a dam, and water is flowing down into a turbine. Let's say this is our turbine. So you have a function that you can use to calculate the energy that the water transfers to the turbine. Right? Now, you have the turbine blades and you have a generator. You have a generator somewhere outside here. Then you have the electric wires coming out. And you have a different function to determine the energy put out through the electric wires from the generator and the turbine combined. So you have two different functions here. One to determine the energy from the water to the turbine blades, and the other to determine the energy from the turbine generator combination to the wires. But then you say, we could just combine these functions. We just combine these functions so that we can use the energy from the water, or the energy input from the water and the generator to calculate the energy going out through the wires. All right? So it's two functions that you can combine here. So knowing the properties of the flow of water, you can just directly combine the energy going out instead of using the two different functions. Now, we're going to look at a few examples of composite functions. Now, there's a general example. It's presented on page 807 of the Mathematics, a Complete Course, Volume 2 by Raymond Tulsi. It says you have a function, if you have a general function, f of x is equal to ax plus b, and you have another general function, it is g of x is equal to cx plus d. Then you can combine these and obtain, for example, f g of x. Now, how do you do that? You have f of g of x. F of a function is going to be ax plus b. Now, this fg of x is really f of g of x. And g of x is this. Now, remember, in earlier videos, we're saying that when you have f of 3, you replace x with 3. For f of x, you want f of 3, you remove x and put 3 there. So what you're going to do is this. For f g of x, we have f of x being a x plus b. Same thing as up here. But we have f of this. So what we will do at this point is remove the x and have this there, fg of x. Same thing as this. You see that? But then we go a bit further. What we can do, right, is this. We have g of x is cx plus d. It is cx plus d. So we have a times cx plus d plus b. So what we have done was to put g into f. Put the one on the right into the one on the left, because we're finding f of g of x. So we put g of x in f. So this cx plus d is the same cx plus d that we have here. Alright? So we put g into f. Now, of course, we can multiply them out. Fg of x is equal to multiply a by c to get a by cx, acx plus ad, and then plus b at the end, if you want to multiply them out like that. Alright? So this is one composite function. Let me divide my whiteboard to separate what I'm going to do next. This time I want g f of x. G f of x. In this case, remember, g of something means cx plus d. G of x means cx plus d. So g of something means c times that something plus d. Now, it's going to be g of this that we want. So, g of f of x. G of whatever it is c times that thing. Let me put it in bracket, whatever I'm going to put here. C times that plus d. You see that? Plus d at the end. But it is g of x. So it is c times, if f, it is g f of x. So what you're finding is c multiplied by the f of x. That's what we have. But then what is f of x? F of x, it was accidental, f of x is ax plus b. So let's remove this and put our ax plus b. This. So what we have now is f is G, not F. G f of x is equal to C ax plus b plus d, the same d, the same c. Alright, you see that? So G f of x is equal to, we can multiply it out, c multiplied by ax, acx, putting it alphabetical order, plus c times b, bc plus d. So generally, that's what happens, right? That's what happens in general when we have two functions that we want to combine or to make a composite function, a function that is a composition of those two functions. So in this case, when we have f g of x, what we do is put g of x into f, the right into the left. And when we have gf of x, we put f into g, the right into the left again. Alright? We're going to look at a few more specific examples in a different video. I call these general examples because we didn't use any numbers. It's just letters that can represent numbers. But the specific examples that we will look at in the next video, they will have specific examples with numbers.